Morning guys, welcome back. So I'm going to start by looking at the few bits of homework that I gave you on transformation geometry. So I went through this really quickly because I was explaining that we've done it this year, so I didn't think it needed kind of a full recap. Okay, so in the question below, three images labelled A, B, and C are the images of the object under a transformation. The transformations could be a translation, an axial symmetry, or a central symmetry. For each image, state which transformation was used. Okay, so the first one there is not upside down or back to front or flipped over, so it's just a translation. Second one is upside down and back to front, which means it's central, and that one is just flipped, and it's flipped through the y-axis. So I'll say axial in the y. A in the next one is your central, upside down and back to front. B is your axial, and C is your translation. And then the last one, A is axial, B is the translation. So then C is central. Okay, and then I asked you to do question 6 as well. So the diagram shows two rectangles, A, B, C, D, and D, F, G, C. D, F, G. Oh yeah, okay, so the one on the left and the one on the right. Find the image of the following under the given transformation. So the image of E, so here's E. And the translation is D to H. Okay, so if I'm just going to do this here. Hang on. Go away. Draw. Let's go green. Insert a line. So it's from D to H. It's that translation. So if I move E under the same translation, where am I going to end up? Yeah, I'm going to end up at C. Okay, and the next one, we want to take the line AB. So, hang on now, and I'll try and just wipe them. Okay, so I'm going to start this one with the line AB, which is here. Yeah, and I want to move it under the translation E to H. Insert line. So I want to go from E to H. Okay, so how many boxes are we moving there? 1, 2, 3, 4, 5, 6. So E is halfway through a box and H is halfway through a box. So that's 1. Yeah. So if we take the kind of half a box here and the half a box here, yeah, that's 1 box. And then we have 2, 3, 4, 5, 6, 7 boxes we're moving it. Okay, and we're moving it just to the right. So 7 boxes to the right. 1, 2, 3, 4, 5, 6, 7. Yeah, that's what I thought. Okay, so if I pick AB, which is here, and I move it 7 boxes directly to the right, I'm going to end up here, which is the line CD. Yeah? Let's take all that off. A, the point A under central symmetry in the point D. Okay, so if we're taking the point A, moving to D, and then moving out the far side, we're going to end up at F. Oh. Like, central symmetry normally ends up with the object being upside down and back to front, but if a point doesn't have any dimensions, so if you turn it upside down or back to front, it doesn't matter, it's still just a point. Do you know what I mean? Triangle ABE. ABE, where is that? Here. Yeah? Central symmetry in the point E. There's your point. Yeah? So if we take A, move it to E, and then move it out the other side, we'll end up at C. If we take B, move it to E, and move it out the other side, we'll end up at D. And you can't move E through itself, so you have your triangle. It's this one here. See it there? E, D, C. Or CDE or CED. It doesn't matter. Okay. Next. AE. Where's AE? AE is here. Axial symmetry in DC. Okay, so DC here is the mirror. So what's the mirror image? So basically you have to move A, here's A, to the mirror, and then the same distance the other side. So it's going to end up here. And then you have to do the same thing with E. Move it to the mirror and move it the same distance the other side. It's going to end up there. So the image of that line is going to be that line there. So what's that? FH. Okay, and the last one, triangle ABE. We looked at that one before, didn't we? ABE. There it is there. Axial symmetry in DC, so same mirror. DC. So A needs to go to the mirror and the same distance the other side, so it'll end up here at F. E needs to go to the mirror and go the same distance the other side, so it'll end up at H. And B will need to go to the mirror and go the same distance the other side, so it'll end up at G. So there is where the triangle ends up. So that is triangle GFH. Yeah? Okay, so that's that. Right, so where were we? Transformation. Yeah, so we're going to start looking at some of the theorems. Now, a lot of these are, like I said, revision of geometry, but you would have done geometry in first year. I spoke about a few of these theorems the other day, okay? Don't worry about their numbers, okay? We're just going to number them as we come across them, so we're not going to call this theorem, well, we are going to call this theorem 1 because it's our first one, but we're just going to work our way through, okay? So the first theorem is that vertically opposite angles are equal in measure. So these are the ones where you have the cross, see it here? You have the cross, and the angles that are opposite each other are equal, okay? So 1 would be equal to 2 and 3 would be equal to 4. And they're called vertically opposite, okay? And you need to call them that, okay? Not just opposite, you need to say vertically opposite, okay? For vertically opposite, you're looking for an X shape, okay? And these are the other ones we talked about. So when you have parallel lines, you can look for a Z shape, which is called an alternate angle. And you can look for an F shape, which is called a corresponding angle. But you can only look for those angles if you have parallel lines. Okay, so Z's and F's only exist if you have parallel lines. Okay? So, come on. Okay, so if you don't have parallel lines, you can't find alternate and corresponding angles. Right. So I don't really like these pictures. I suppose these two here are probably the best. Okay, these ones here. So you have here's your first line, and here's your parallel line. Yeah? This line that crosses them, see this line here? That line is called a transversal. Yeah? And then you go looking for your Z shape. Okay, so you start on the parallel line, go down the transversal, and finish on the other parallel line. And you've made the shape of a Z. And then these angles are alternate and equal. Okay, so if you have parallel lines, alternate, and that's angles on a Z, alternate angles are equal. Okay, so if you have parallel lines, you're transversal, and you find that Z shape, then those angles are equal. Oh, it's very slow. Okay. The Z doesn't have to be, so obviously that one I coloured in there is an actual Z. Okay, it's pointing in, like it's in the same orientation as to how you'd write a Z if you were writing the word zoo, for example. So here, when we talk about the Z, it's referring to a Z shape, okay, not the letter. Okay, so it's a Z shape as opposed to the letter. So that shape could be exactly like the letter. Apparently I can't do a backwards Z. It could be backwards. It could be sideways. Okay, so it's the Z shape you're looking for. Okay, and if you can find the shape, then the alternate angles, see them? Alternate, 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 okay? Those angles are equal. Okay, and then we have the corresponding angles. So if we look down here, okay, so again, we have our parallel lines. Yeah. Again, we have a transversal. Okay. This time, you're looking for an F shape. So look, one arm of the F is on a parallel line. The other arm of the F is on a parallel line. And then the body of the F is the transversal. See that? These angles are called corresponding angles. So if you have parallel lines, okay. If you have parallel lines corresponding And there your F angles are equal. Okay? So that is the first theorem, is your vertically opposite angles are equal in measure. The second theorem is there. If a transversal makes equal alternate angles on two lines, then the lines are parallel, and you can say it the converse way. So if two lines are parallel, then the alternate angles are equal, which is kind of the way I said it. And then this here is number 3. Two lines are parallel if and only if for any transversal corresponding angles are equal. Okay, so we have vertically opposite, which is the X shape. We have alternate, which will only happen if you have parallel lines. And to find alternate angles, you need to find the Z shape. And we have corresponding. Again, corresponding angles will only be found on parallel lines. And you need to look for the F shape. Okay, so there are the 3. Now, where are my questions? Okay, so here are a couple of questions that I want you to try. Okay, so just using those 3 facts, I'm going to try really hard to make sure I don't give you anything that is not appropriate. So the first one, we have to classify each of the following pairs of angles using the diagram below. The first pair has been done for you. So they're saying that angle 1 and angle 4 are vertically opposite. Okay, next thing they're talking about is angle 3 and angle 7. So is there a relation there? And remember, you only know 3 things. So they're going to be either vertically opposite, they're going to be corresponding, or they're going to be alternate. Okay, and you need to decide, is there an X between them? Is there an F between them? Or is there a Z between them? And then from there you can decide. Okay, and then I would like you to do A and B of question 2, which is where you're actually finding the size of angles. Okay, and again, you're just using those 3 facts, nothing else, just the 3 things we talked about, okay? Sorry, Monday the 22nd. There is the first one, and then these 2. Okay, so I kind of like these questions. They're like little puzzles to solve. Okay, so all of the questions I've given you have parallel lines, which means both alternate and corresponding are viable options for them. Okay, so you are going to be able to figure these out either using vertically opposite, which is the X, alternate, which is the Z, and corresponding, which is the F. Okay, so give those 3 questions a go for Wednesday, please. All right, thanks, guys. Let me know if you have any issues.